According to Lloyd's List, the global shipping industry emitted approximately 833 million tonnes of CO2 in 2021, a 4.9% increase compared to the previous year. Despite commitments from the IMO to reduce emissions, things just don't seem to be going in the right direction, which is strange because technologies do exist that would reduce the amount of fuel that ships burn and their associated emissions. One of the most promising was actually developed in the 1920s by Anton Flettner, the rotor sail. He fitted 2 huge cylinders to a cargo ship, which would spin around, making use of the Magnus effect to generate thrust. Jump forward 100 years and you can still see a few modern ships using rotor sails to reduce both fuel consumption and greenhouse gas emissions. Essentially, a cylinder spinning in an airflow will deflect the flow of air, then, thanks to Newton's third law of motion, an equal and opposite force is exerted on the rotor and felt by the vessel as thrust. It basically acts as a sail, taking energy from the wind and using it to help drive the ship forward, reducing the demand on the main engines and emissions. Although significant fuel and cost savings are possible, the technology just hasn't caught on due to a peculiarity in how the shipping industry works. You see, ships are owned by an owner but operated by a charterer. A rotor sail would need to be installed and paid for by an owner, yet it would be the charterer who benefits from reduced fuel costs. For the owner to get a return on their investment, they would need to raise their charter rates. The charterer would then have a choice between a cheaper vessel with no rotor or a more expensive vessel with a rotor that might save them enough to justify the higher cost. But what if there was a third party that could invest instead? Say, someone wanting to reduce a ship's emissions to obtain a stream of verified carbon credits. The ship's owner gets a more attractive vessel, the charterer gets lower running costs, and the investor gets the carbon credit. The thing is, existing designs of rotors have limitations when it comes to investing. Primarily, they're massive heavy structures permanently attached to a vessel. They're typically over-engineered as they need to be able to cope with potential hurricane-force winds in excess of 150 knots. This makes them quite a gamble because what if you invested and then the ship gets laid up for a year? Your investment would be stuck. So instead, we've developed a new type of rotor specifically designed to suit the carbon investment market. Let me introduce the Reefing Rotor sail. It relies on a technology that's already used in the aerospace, automotive, manufacturing and entertainment industries, the helical band actuator, commonly known as a spiralift. For the curious, multiple YouTube videos do provide greater detail on the inner functions of spiralifts. Traditional uses are for smooth lifting applications where the inherent stability of the metal column allows for precise deployment. In the Reefing Rotor sail, we use that same technology to create a rotor that can be retracted into a deck housing approximately 2 meters high. The rotor itself is self-supporting, but we still have a telescoping carbon fibre mast on the inside to transmit the thrust to the structural members of the vessel. What this means is that the only permanent attachments to the ship are an approximately 20 foot long, roughly 18-inch diameter steel tube, as well as a connection to the ship's power supply. Other than that, the entire unit is designed to be lifted off so that it can easily be moved between vessels. To install it on a new ship, you simply bolt the deck housing in place and connect the power supply. The Reefing Rotor sail is controlled from a panel on the bridge which is capable of automatically adjusting the rotation speed to generate the most thrust and even reefing the sail when conditions require. For example, when wind speeds exceed the design parameters of the sail or when the apparent wind direction is right ahead so that it doesn't create additional drag. You can also retract the sail to pass under low bridges or when in port so that it doesn't interfere with cargo operations. Of course, whenever it's needed, you can unbolt the deck housing and remove the Reefing Rotor sail entirely and just transfer it to another vessel on a flatbed truck. This is particularly useful in situations such as the trading area of the vessel is changing to one with less favourable conditions, or the crew are not operating it in the most effective way, or even if the vessel is going to be laid up. If, on the other hand, you find a vessel is especially good at operating their sail, you can simply fit more units on the same vessel. It's common for ships with rotors fitted to have multiple units, but the transferability of these Reefing Rotor sails means that you don't need to commit to installing them all on one vessel straight away. The investability of the Reefing Rotor sail means that everyone is happy. For the ship owner, they get a host of benefits at no additional cost. The charterer gets a vessel with significantly reduced running costs at the same charter rate as any other vessel, and the investor gets a stream of verified carbon credits from multiple Reefing Rotor sails on different vessels that can be moved around as required. The ability of the system to reef the sail means that the ships on which it is fitted can operate in the same way they always have done, when required, yet on passage, when the conditions are favourable, they can deploy a Magnus rotor and use the wind to reduce demand on their engine and reduce their emissions, which then gets credited back to the owner of the sail, you, the investor. For more information, go and check out our website, reefingrotorsail.com. From there, you can follow the links and get in touch with us directly.